Like we said in the last video, many redox reactions involve reaction of a substance with oxygen. So combustion is a reaction in which one substance reacts with oxygen. So here we are seeing an example of hydrogen reacting with oxygen to form gaseous water. Now, there are also redox reactions without combustion as well. Electrons in this case are transferred from sodium to chlorine to form sodium chloride. So first, sodium forms sodium ions, right, and chloride forms chloride ions, and then the ionic bond between sodium positive ion and chloride negative ion to form sodium chloride. And this is a electron transfer reaction, so it is also one type of redox reaction. Now, reactions involve metal reacting with non-metal are also electron transfer reactions, and so they're also one type of redox reaction. So in the first case, if you think about it, you form sodium oxide, and if you think about it, sodium oxide is 2 sodium ions in chemical combination with oxide ion. Just like the previous slide, sodium chloride formation is a reaction between sodium and chloride ion. So these are some general redox reactions. Now what you need to remember though is that transfer of electrons does not need to be a complete transfer. Okay, it can also be sharing or unequal sharing of electrons. So if, for example, when hydrogen chloride forms, chlorine has a larger share of the electrons. If this is the bond between hydrogen and chloride, if this is a bond between hydrogen and chloride, one bond includes 2 electrons. Chlorine likes to attract those electrons towards itself, and so this is unequal or uneven sharing of electrons. So this can also be considered as a redox reaction. So when this hydrogen chloride bond is formed, the formation of this bond is also redox reaction. So when we say transfer of electrons, it does not need to be a complete transfer for it to be a redox reaction. So now in a reaction where it is easy or where it is very obvious to see where the electron transfer is happening, it is easier for us to tell which atoms are losing electrons and what is oxidized and what is reduced. For example, in a reaction like this, right, I'm writing the charges here just to show which atom forms the cation and which atom forms the anion. So here in this, it's very easy to see that sodium loses an electron to form sodium ion. Okay, and so we say that sodium is being oxidized. Okay, now chlorine on the other hand gains electrons to form chloride ion. So chlorine is being reduced. So where it is obvious for us to see the transfer of electron, which atom is losing the electron and which atom is gaining the electron, we can simply point to the atom that is losing electron and say that atom is being oxidized, and point to the atom that's gaining electron and say it is reduced. But not all reactions are simple like that. So in the next video, we're going to find out, or we're going to talk about the method by which we can find out what is being reduced and what is being oxidized.